So there we are. Okay, cleaning up stuff from the last time. And my microphone is on. Okay, let's do that. So first of all, I think I disabled the gravity, right? Let's put the gravity back in. And I'm also very nervously test a lot of times. Rather testing more often than not enough. And it goes boing. No, it doesn't go boing. Yeah, exactly. And then it goes in there. And now it moves back in. It was not like that the last time. Then let's also crank up the FPS again. Where was that? Here. 30. Don't go crazy in the beginning. What would be nice if we would have some kind of debugging for every frame, and then just can click when we want to progress with the frame. But for that, to dive in if that kind of works with the Visual Studio Code here. Run and debug. Python install Python debugger. Let's go. Python file. Okay, and so that we don't have to wait, have to wait too long. What I want to do is to not make it an acceleration first. So move that to 0 again, and but we start with a constant velocity. Something like that. What do we do? Maybe 2, I don't know. Let's try it out. Let's try out a lot of times. Yep. That works nicely. Kind of. But not. Then maybe the acceleration is then the problem. What was that? I mean, it's funny, but it's also a little bit also want to make you cry. Okay, so what do we observe? You have to write down the observations. Write it in the collisions here. No collision detected when constant acceleration. No collision detected when key is held down. Right, so that's what I kind of just saw here. Let's just see if that really is the case. So if I click right, it only corrects when I let go of the key. And then it corrects with quite some force in some instances. So, and what we also need to do is to correct the update position. Yep. Yeah, so I think it kind of works basically. Run and debug. Nope. Wrong file. So I would have a call stack here. If I just, but where's the, yeah, stop. Then I have a call stack and I have some variables. Yeah, and that should probably help me debug. I can then maybe just set that I just press a button instead of an automatic ticking of the clock, and then I can really control which workspace state I can look at. Okay, let's just close this up. Right. So these are two problems. Okay, then let's do this. We don't make it clock tick, but we wait for a button press. And once again, not afraid to use ChatGPT. Let's see. Now let's just try it out first by myself. So while running, and go to next frame. Very clear variable names here. It's true in the beginning. Cannot type today. And then in the beginning, this goes to false, because then I can hopefully it's not super elegant, but if I say like while, that will block a lot. Okay, I asked ChatGPT. We have this event key here again. But I don't want to go in here again. So something like that. Will it work? Not quite. While running, what's the difference here? We also have this variable here that it's running. But maybe I here do the clock tick here. Maybe this has something to do with not making it stuck. Okay, it's also again stuck. Maybe I also need this clock tick here. Nope. Okay, I need to get a feeling for this. This should work again, hopefully. Sanity check. Yep. Works. But now happens if I remove this one? Then it just goes crazy because it can go fast. I see. Okay. So maybe it doesn't like the nested while loops. Yeah, let's try that out like that. Ah, okay, it goes in the beginning. But then I have to reset it always. Let's try that out. Yeah. getting closer. Okay. Yeah, then we have to reset it back to false in the beginning. Then we could actually also remove that here, I think. Haha. It's actually quite good to have this overview now. I have to do that. I want to feel it in my hands probably soon. Okay, so what can we see here? Bouncing around like this already is here, leaves a gap. No. Okay, sometimes it leaves a gap, sometimes it doesn't. It appears like it. I mean, yeah, we need a lot more debugging tools here. For example, also to set the velocity and the angle or something in a way that we want, and then let the simulation run. So let's start maybe with a little bit of a dashboard of the different. Oh wait, we don't even need that. We could just now maybe just run the Python file here. Nope, that's not what I wanted. I wanted to run and debug. Normally there's a little debug sign here. It bugs me that it's not there. But yeah. Okay, and then we could go stop, and hopefully we have the variables here. Nope. Here in module. Yeah, and then we can basically drag that down. Would be great if you could also set the velocity and so on. By here, but debug console. If I say now, what was this player called? Player dot x equals 0. If I do that, so continue. Then it's here. Okay, cool. Okay, that works. That makes things easier to kind of debug. And then we can. Does it also work if I do it like this now? Discovering debugging here. Game debugging. Okay. Maybe I should hit stop first. No? Okay. I have to kind of go into the call stack, and then let's see, continue, and then it's in the middle again. Okay. Would be cooler if it could be like kind of graphical with the mouse, a little bit more intuitive. But that's fine too. That should help. Okay. So how can we use it now for finding out if the collisions work? Could probably also set some breakpoints here. Actually, breakpoints should also not be too bad. Maybe that could have actually could replace this whole button press. Yeah. So what do I want to find out now? In every frame, I want to see basically what happens here. And let's remove the other circle that's on the top. That was this one. Just for now. Run and see. Yeah. Yeah. Be back in a second. So. Breakpoints. I want to set them here. So in every step it checks for the overlap. And then I can just run this test. Yeah. Okay, so let's see. Then I guess I remove this guy over here again. Then the indentation won't work maybe. I don't know. Let's do that here again. And yeah, here goes nothing. Just work myself through the errors, I guess. Error. What? Ah. SDSFet, what's that? What's this coming from? Okay, but the indentation didn't make a problem, that's good. Then I can just check, I guess, in the debug console, and then we get this guy and see the overlap is false. Okay, let's continue and check again. Overlap still false. I mean, we basically also want to see the screen of the game. Don't we? So let's move it like so. And where's my where's my debugging little window thingy? Debug console, where is it? Debug console. Debugging tools or something. Guess maybe I have to kind of lock that down here. Is it possible? No? Figuring stuff out. Here it is. Come here. Okay. Go next. And it doesn't really draw, huh? Why doesn't it draw? That's not super helpful. Okay, right, but the number of steps here, this maybe is also something that could be optimized. Entwicklung. So however much the velocity is, will be divided by 2. And this might also be the reason why the acceleration is not really in there. Because, of course, the acceleration should also play a role in the end steps. Haha. So what if I always make 30 steps? For now. Let's just also doesn't also really make sense, huh? I mean the velocity is just in pixels or something, and then dividing the pixels by 2 and making it an integer then of course sometimes it's just 0, I guess. No integer. Now I'm a little bit stupid. I have to. Was integer rounds up or down? What was it? Which way was it? Yeah, it rounds down. Right, I knew it. So then sometimes it's just 0 steps. And then it doesn't go in there at all. Haha. Okay, so this definitely needs to be fixed. Reasonable number. It was a little bit too simplified. Let's erase this guy and let's get another debugging session going. Okay. So now I'm kind of interested what will happen if I put the acceleration back in. What's happening? Come on, gravity, do your thing. I really need to fix the movement controls here. Bounces and it kind of stays on the surface. Is this because I have this ground test active? Huh. Or am I being too confident in myself? Wrap around the screen, ground underneath. Is it still being tested? If so, I would like to remove it. But then it should also work for the velocity. Actually, no. That's not active. Yeah, maybe because it's adding up with the acceleration somehow, and the correction will just make it don't bounce so high anymore again or something. Or rather, okay, let's fix two things. The key press velocity application, and that it kind of is not checking for collisions when as long as I press the keys. That should not be the case. Actually, I think I will look at my other game which I made and see how I did it there. But first of all, What was I gonna do? Oh yeah, I wanted to remove the gravity again. Okay, quick test. Alrighty. Then let's go to GitHub, my other game. And this guy. Well, it was in JavaScript. I have to translate now. So that was something about a key press. React to key presses. Okay, it really only moves the position. I see. This was rather easy. But how does it resolve the collision then? Yeah, it sets the velocity based on the observation. Which is fine in this regard, because there were no other forces really that needed to be considered. But in my case, that should be considered. So let's get a notepad for extended cognition. We have key press should affect velocity. I mean, isn't it adding to the velocity somehow? Or is that... it needs a cap. If I just go... I add to the velocity, then it's getting too fast. I mean, I could actually cap the speed or the velocity anyway. Because of friction and stuff. Let's just try it out. I mean, for now, it should probably be moving very quickly. No, there's no cap, and so... But with a cap, it should actually do what I want to do. And then I also want to figure out why that's such a... why the speed is not conserved. If I move here, the correction vector is doing something with my velocity, what I don't want. Okay, let's also write this in the observations of the collision correction. So we have adjustment also is difficult to predict intuitively. Definitely not the same velocity as before, which needs to be fixed. But yeah, I think first of all with the cap and the velocity here, we can make it look actually quite good. And we check the current speed via taking the velocity vector and grabbing our utility function, which is the distance of 2 points. The points being points being 0, 0, and the velocity. So well x and well y. Let's call it just well. And check gravity cap. Where did I apply this actually? So actually this guy maybe we want to use again. And maybe call it max speed. Yeah, let's make it. Not on Maxwell. Maxwell's equations. Hahaha. Player circle. It's not gravity cap no more. It's Maxwell. Self Maxwell. Maxwell. Where do we still have this gravity cap? It's in here. And here. But I don't want it here no more. I want it to be here. And then it allows me to check not just the y direction, but like the whole vector, of course. If val is larger than self Maxwell, now we need to adjust the velocity so that it's going at the maximum velocity. How do we do that? Mathematics. Never been good at it. I mean, also not really bad, but I mean, just it was always a little bit of a struggle for me. Yeah, so we want to divide these numbers by something. By what though? By what though? Is it Python? This is Python speak? I forget so many things here. Python works. Yeah. Okay. Yeah, I don't want to just divide by this one, right? That's not making much sense. I want to divide it, so I mean it's a percentage. No, maybe no, I want to divide it by the current velocity so that I can get a unit vector. And then multiply it by Maxwell. Haha. That should do it. Okay, let's run her again. Yeah, that looks good. And now I also cannot get inside anymore. I mean, I guess that's because the simulation steps were not really set correctly. Okay, let's write this thought down. What I just did was that so this is then also solved. Haha, we cleared a to-do. Okay, this in here we can clear another to-do. Isn't that nice? And since we're at it, no, let's keep this one. So now let's think again. How to adjust the velocity based on bouncing off of something, right? I mean, it's like an immovable object, and if it's, I mean, it should keep the same velocity as before, I guess. but why does it change anyway? I don't know. Man, we could also just set the velocity to 0, just for fun. Let's see how that feels like. If we have a collision and we correct for it, then let's just for fun set the velocity to 0. Because I'm cool, I write this in one line. Okay. It doesn't correct correctly. And if I keep it pressed, then it's still. So what I also basically want is that the velocity dies off at some point. Yeah, and that was basically a friction parameter, right? So that in every update the velocity is removed or is reduced by friction. Really have to bundle these things together in some kind of world class or something. But for now, do it like this. And this is of course then not super fair for the diagonal movements. But I guess that's okay. Let's see. Okay, let's see. Yeah, this fiction needs to go into the player also. And let's test it out. Oh no. Wrong direction, wrong direction. Was it like... But shouldn't it be minus equals friction? And yeah. And then of course, yeah, it shouldn't go negative. Yeah. How do I do with the negative ones now? The negative directions. I mean, I could make it a... Make it so... And make it a percentage. Yeah, it dies out, but way too slowly. No, it's a little bit... Oops. Personal stuff. Didn't I close WhatsApp? It's not shown. Okay, but long story short, we have a few more problems. Do have a few more problems. So what I want to maybe tackle now is why can I just move through that if I keep my keys pressed? I update the position of the player, but this happens in a... I don't know actually. Right now at least. Keys, key press, player, update position. goes into this update function here. And the velocity is adjusted. What is the stack here? The player updates and only then it checks for the collisions. What happens again when I do this? Okay, now it doesn't go through, which is good, I guess. But I want to understand why. What is the difference here? That the check for the collisions comes first. I mean, I guess it makes sense. The position is updated. And then everything is applied here. Yeah, I think that's good for me. Good enough for me. Boing. I don't want to have this bounciness going on. I mean, I guess it's not super easy to solve this one, because everything kind of operates now the level of the velocity. And here the correction vector is about the vector update position. And in the update position now I add it to the velocity, right? Actually, it looks good now. Or not. I think it doesn't look too bad. But okay, let's just write a thought down, what we learned here. All right. Maybe I just now make some kind of world class with all the physics stuff. Like, I don't want this. like gravity, friction. And that's it for now. Self gravity equals gravity and self friction equals friction. So now we can take this one and say we want to have a world and then we can probably set some basic starting values, like this guy, and friction was, what was it again, 0.5? No, 9. Okay. And this was percentage of velocity kept. Between frames. That's acceleration in y direction. Okay, with this now we can go here, remove this one, remove this one. I think this one is not used anymore. Oh no, it is. Now I want to give it a world parameter. Which position was it again? Before the Maxwell. Right. Okay. And then this one goes away. Self-acceleration equals world dot gravity. So where else did we have gravity? Only here. And where did we have the friction? Have to make it a global parameter in this class. And then we can take this one here and do it like this. So now it's a little bit cleaner. Right, so it looked like it might be not too bad now. Oh, it's so slow. What is happening? I mean, it doesn't go inside anymore, that's good. I guess. But whatever that is also not really good. So the velocity correction is not really working as it should. Should the velocity actually be changed here? Once again, I kind of refer to my... Why is the gravity so slow? What is that? That's too slow. Is the gravity cap still in there? No. Does the Maxwell change how quick the ball falls? For now, I also remove the other obstacle. Why is the gravity so slow? Thought it should accelerate like crazy. At least as fast as when I move it with my fingers, with my keys. Okay, this now looks faster. Huh, okay, okay. Interesting. So what I don't quite understand. Okay, I have Maxwell here at 10. And I have the gravity at 0.5. So it's adds this every frame. To check if the velocity is adjusted. If I don't press anything, it's just the gravity. It's not going in there, so that's not the reason why it is slower. And then it only seems to depend on this guy here. If I go at 1, then it falls, but it's still not adjusted. If I go crazy and say 2, then it is adjusted. Okay, just didn't hit the threshold yet. But that's too much. But it's so the speed reach depends on this one, but it should actually always be more and more. Because that's what acceleration does. Acceleration y plus equals acceleration y. It's not going. Higher than 10. There's some kind of cap here. Why is that? Gravity is 1. Yeah, we also have the friction. Maybe it has to do with this one. If we don't do the friction, it goes to 11. Okay. That seems to be the maximum as well, because if I press, it doesn't change the speed. Or actually it does. Looking at the numbers. But no, it doesn't get faster. It's also kept off. Huh? Why? Where is it stopping? So then let's also remove that one. And now it goes faster and faster. Okay. So it's this one, but it doesn't adjust to the number that I wanted. Maybe it's also a little bit again of the stack order that's important here. What if I move this guys up here? Yeah. No. Same thing. So let's just move it down because it's more intuitive for me. It's another print. Yeah, this one I don't want anymore. So we have what we have here. Maximum velocity is 10, current velocity is 11, and new velocity is 10. Okay, so it's got corrected as it should. If I now press the key down. Ah, okay, yeah. No, the new velocity also stays. Okay. So maybe it was the friction then. Let's... So it seems like it's an interaction with the friction. That the gravity is slower, or quite a bit slower. But the friction, I actually don't want to apply that to the velocity. To the acceleration. So that means that the friction should go before I guess, or before the acceleration is applied. So that's okay for now. Okay, I think it works. It's not going slower than when I press the keys. Yeah, that should do it. Let's write down this inside in the comment. Okay. Let's add the lower obstacle back in. Boing, 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 jong, jong. No. So once again, there's something off with the correction vector here. It bounces and it bounces even higher. I mean, what should be expected is that it maybe bounces a little bit, but yeah, not that much, and it should reduce the bounce over time. Okay, now it looks like it's bouncing at the same height all the time, but there's also some time where it adjusts a little bit. Okay, let's maybe change the gravity values here a little bit again. 0.5 should do it. Yeah, friction. And let's also maybe go down to 30 FPS again. Yeah, it's bounced in higher at some times. It shouldn't be the case. So that's the big problem here still. Yeah, so the correction is not as good as it should be. Then we have the sunset again. Bloop. Bloop. Yeah, that doesn't quite work. So now I'm thinking that we move this one into the outer loop. I think, yeah, because otherwise it just keeps running when it found the overlap. So not super sure about where to put it exactly, but I think I put it here, and then this one goes back 1. Then we do this guy. I'm kind of zweckentfremden this. Yeah. Kind of probably misuse this one. Yeah, actually I don't need this. I just want to break out of this for loop here, and then want to still check all the others. So this guy hopefully prevents weird bouncy behavior. Yeah, so then I can move it also again outside. Don't need this comment anymore. Okay, let's test it out. I'm very eager to see what changed. Nice. Hello. Okay, the only problem is it kind of goes in deep in the beginning. Nice, I like it. Okay, yeah, that was definitely a problem. I like this quite a bit. But now we have to add to the observation that it's quite, you know, merging into this shape. I think that's solved. How's it immersing? Yeah, so that's probably needed. Can just try it out and crank the virtual steps up to 60, which should at some point then really be straining on the performance, but it's also not really changing things here, except that it's slower. Can also see it when I press down. Yeah. Yeah, it's pretty visible when the keys aren't there. So it's kind of cool, you know. It really demonstrates that I really would have to be perfectly in the middle to not slide down here. So it's completely circular. It's kind of nice. So let me just run it again, just really start in the middle. I could actually also have just paused it and set my velocity to 0 and everything and position to 0 in the x-axis. which is not, I mean, half of the screen width. Yeah, if I press down, merging inside. Okay. But I guess, sorry about the loudness, but I guess that's a problem for another day. What I want to do now is just to make some random obstacles again. It's really cute to see that it kind of works. And now it kind of gets stuck here. And it also, it's kind of nice that it kind of rests at some point. So that's some kind of emergent behavior. There might be probably with such a, yeah, a little bit chaotic physics engine, it's probably conceivable that there's some things where it could really get stuck. So some, or it just keeps bouncing. But it seems like here at least it looks quite good. Let's make a few more. Now I've apparently started within one. And actually I also want to set a minimum size here of 5 at least. Yeah, let's do it like so. Let's save this bad boy. Get that. Okay, let's call it a day. And until the next time, bye bye.